All right, we're back. We're still on page 201. We've done parts A, B, and C. I'm assuming you're following along or you've already completed them, whichever. We're going to do part D. So is it possible? Nope, it is possible to set a third target in motion at the same, what am I doing? You know, reading is hard. It is possible to set a third target in motion at the same starting time that will always be exactly halfway between the first two targets, as long as the original two targets are moving. Okay. I think you could actually do it anyway, but it would be a little more challenging if you want like one of them to stop and whatever. But whatever. Find the starting and ending points and a set of parametric equations for the target. Make a table that supports the fact that target 3 is always halfway between the other two targets. Okay. So I think that it's pretty clear that we could do this, maybe. I'm gonna switch over to GeoGebra before I like try to actually solve this. I'm gonna hide some stuff. I don't need to see this line. And I mean, I guess I can leave everything else. Like these are the, oh, you know what though? These points are gonna move when I change the slider. And do I wanna do something about that? I don't think I do. Is there a way to like make this point on? I don't expect anyone to answer because I'm in a room by myself. There should be a way to like make this point a free point, you know, like so that it's always that instead of something dynamic. But whatever, we'll put it back at 3 if we need to see it at 3, I guess. All right, so what I'm thinking is, I mean, I just need the midpoint, right? So GeoGebra actually can do that somehow. I'm under the impression that I can do that. Where is it? Point. Blah, 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 blah. Midpoint. So I want the midpoint, right, of this and this. And then let's move V and see what happens as they move. Okay, so at time 0, we're just going to be the midpoint. I thought I told you to go away, line. Wait, you're not the line. What are you? Oh, you're the line. Okay, go away. Let's change the color of this. Click. I'm going to click up here, and we'll make you green. Green is not my favorite. Let's make you orange. I feel like the brighter colors, the more vibrant colors are a little better. So this is going to be T3, target 3. So settings, caption, T3, show label, caption, and there. All right, so at T equals 0, at time 0, we just need the midpoint of the segment connecting T1 and T2. That'll be the starting point. And then the ending point is going to be when they, so it ends when, what? Oh, it ends when they are both done moving, which happens at T equals 20. So right there. So if we just find the midpoint of their positions at T equals 20, that'll be where we end. And then I think we can go from there. So I feel pretty set up to do that potentially. And if I know the start and the stop, so actually there's 2 ways I can do this. So what is the question? Find the starting and ending points and a set of parametric equations. Okay. I'm gonna do 2 different things. So it took me a while to understand the question, but I think that's natural. Like when you read a question, you don't automatically know how to solve it. So we're just finding the midpoint of the segment, connecting. I forgot how to make a G there for a second. Connecting. I think I type SEQ. I write SEQ a lot for sequence. So like that was weird. T1 and T2. All right. So I want to do T. So at T equals 0, T3, I guess, of 0 will just be T1 of 0 plus T2 of 0, and then divide by 2. And then since T2 stops at 20 and T1 stops at 20 and T2 stops at like 26 something, we only want it when they're both moving, so we're going to use 20. T20, we'll get T3 of 20, which should be T1 of 20 plus T2 of 20 divided by 2. calculator is going to do the work for that. So like, don't freak out about that. So let's see if we can do this. So I'm switching to the calculator. I have two ideas of how to do this. So the first idea, I'm gonna add another calculator page. And I'm just gonna find, what should I do here? You know, I think I can actually do this. T1 of t is gonna be x1 of t comma y1 of t. So I did that so that I can just do t1 of 0 and get the point 0, -5. I'm gonna do the same thing for t2 because it's a little easier to work with in the context in which we're doing these problems. So t2 of 0. And then I need the midpoint of that. So I can actually just do like t1 of 0 plus t2 of 0 divided by 2. So that's going to be the starting point. So I'm writing that down on like my paper, on my iPad, I guess. And then repeat the process for 20. And we get, okay, that's great. 169 over 56 and 8843 over 896. Okay, so that's where you are at the start and the stop. So we need parametric equations. So I'm writing down the like beginning of these, and then I'll obviously go back to the notes so you can see what I'm writing. But I'm going to do it mostly on the calculator here. So what I could do is I can do, so the starting x value is going to be, is 5, right? Because the initial point is 5. So I could say that I'm going to write it here, 5 plus, and then the change in x is what? 169 over 56 minus 5 times t, right? So I get this, I think. So this, I think, is what x is going to do. And then y at 0 is -3/2. So -3/2 plus the final y is 8843 over 896 minus the initial y is -3/2, and that'll be times t. So I think that these are going to be the equations that we get, I think. So why do I think that I can do it a different way that's going to be significantly easier? I don't really know. Let me write these down and just see 111t over 56, and then -3/2 plus 10187 over 896 t 0t 20. So my other thought was that I feel like I should just be able to like average the equations, right? Like the parametrics. So I think I should be able to get the same-ish result by doing x, like I think I should be able to do x1 of t plus x2 of t divided by 2. And let me expand that. So 5 minus 1. So it's got a different denominator. Why is that? 1. I mean, maybe I'm wrong. Maybe I'm, so that would be the midpoint. That would be the midpoint. T equals 0, t equals. So maybe, oh, you know what? Does that not take the right amount of time? It doesn't. That doesn't take time into consideration. Oh my God, I didn't take time into consideration either. Maybe that does take time. It's supposed to take 0 to 20. How long does this thing take? Oh, it must take 0 to 20. That's the only option. So really, hold on, got to modify something here. This over 20. That's my change in x. I got to do it in 20 seconds. And then, or that was my change in y. And then here, do I not know what I'm doing? It's possible. This needs to be over 20. What if this gives me what I had before? Oh, it does. Okay. Okay, hold on now. Hold on now. I think I know what I'm doing. So delete you, delete you. I was wrong about how I did that. I'm gonna have to fix that on the handwritten stuff. Because I forgot time. I forgot time should take 20. So am I right? I don't know. But let me first just update on paper. So 1120. You'll never even know that I made the mistake except for the video evidence. Okay, I think that these are our equations, and I think that what we can actually do is x1 of t plus x2 of t divided by 2. Just find the midpoint, and we get this. And if I expand this, if I spell expand right, expand x. Oh man, this isn't going well. All right, expand, delete, delete, delete. You can see that those are the same. And then if I do y1 of t plus y2 of t over 2, and I expand, oh my God, expand that, I get -3. Yeah, yes, it works. So this is what we got. We get the same thing. Okay, so significantly easier way to do it. Let's go back to the notes. And like, can we make GeoGebra do this? Like, yeah. Do we want to? I do. I don't know about you. So these are our things, right? So because I had initially forgot to take 20 into account. I just like didn't put in the time. I just did. I said that it took 1 second basically instead of 20. These definitely work. Or we could just do x3 of t. Well, x3, and we know it's of t. You don't really write that by hand. Is x1 of t plus x2 of t over 2, and y3 is y1 of t plus y2 of t over 2. That works equally, that works better, really. I mean, I'm saying like equally well, better. Should I try to do this on GeoGebra? I guess. I mean, I want to. I don't want to like spend the rest of my life doing it, but I'm going to try to spend the rest of my life doing it. So let's do, I'm just going to type it in. I was going to try to do something like clever, but this is not that bad to type in. Especially because you have a keyboard when you're on this. And then plus 10187 tab. Oh no, don't hit tab, apparently. Oh, but you get it back. Okay. 17920 t 0 to 20. Oh, look at that. That's pretty good. I'm gonna put a point on there. So d, it's definitely d of the minimum of v and 20. And then let's do d of 0. So that's the initial point, which is what we got, and d of 20, which is, I guess that's the ending point. I didn't get decimals for that, but that feels right. So I'm gonna hide this. Well, I'm gonna leave that. I'm actually gonna, am I gonna hide this midpoint? I don't know what I'm doing. So I'm gonna move v and see if it worked. Yeah, I think it definitely worked. And then both of those, well, now that's, oh, there you go. So what's happening there is that GeoGebra is stopping T1 and then having T3 is always the midpoint, so it like keeps going. That's pretty neat. I'm gonna actually just hide that point and then rename this one so that it's like doing what we wanted it to do. But wait, what point am I doing? This point. Settings. This is all like, there's no reason to do this, but I'm doing it. This basic, your T3. Well, I'm pretty sure, and I want you to show the caption. I do not see it, so I don't know. Oh, did I just do the whole wrong thing? I did. Sometimes I don't really know, like T3. It's like the thing that you get the settings for is not always what you think. Like I accidentally did it for the slider, I guess. All right, can I move this? Where's the slider? There we go. Very nice. Now, why does T3 sit underneath? I don't know why it like sits underneath its starting point and ending point instead of above it, but like that is not a problem that we need to solve right now. Okay, I'm gonna end this here because you know, I think we've spent enough time on this. But it's cool like that we can just average them to find the midpoint. It makes sense because we can just add them to like get like the ellipse that was going around the point that's moving along a line or whatever. So it makes sense we can do it, but like, you know, until you do it, you're never really sure. Anyway, I'm gonna stop this here. I will come back in the next one and try to answer the next thing. So see you there.